One of the more complicated types of limits we can see would be a limit involving a complex fraction. A complex fraction is where you have fractions within a bigger fraction. So for instance, if I'm looking for the limit as x is approaching 0 of 1 over x plus 7 minus 1 over 7 over x, that can a lot of times look very daunting at first. Well, first of all, the thing we need to do before we do anything else is always plug in your limit to see what we end up with. In this case, if I plug in 0 for x, I end up with 1 over 7 minus 1 over 7, so 0 on top, over 0 on the bottom. Anytime we end up with 0 over 0, we know that's going to be what we've referred to as the indeterminate form, which means there probably really is an answer. You're just going to have to do more work to actually find that. Oftentimes, the more work we're going to have to do would be something algebraic. So in this case, if I'm trying to solve this limit problem, I need to figure out how to simplify this complex fraction. Well, the first thing would be to eliminate the fractions in the numerator. In order to eliminate the fractions in the numerator, I need to get those down to just single terms, which means I need to multiply by the common denominator, or oftentimes we will call that the least common multiple. Well, looking at my two different denominators, I have x plus 7 and 7, so the least common multiple of both of those would be 7 times x plus 7. That would be the common denominator of the two fractions, and whatever I multiply to one side, I want to multiply to the other. That way I'm not actually changing anything mathematically, I'm just multiplying by 1 in disguise, but this will actually allow me to simplify the numerator and make this an easier problem to solve. So here's one of the trickiest parts. I'm going to take everything that's in this numerator and distribute it to the first fraction, then distribute that to the second fraction. So if I take that numerator right here and distribute that to the first fraction, notice when you multiply to the fraction, you would actually put what I have circled in yellow in the numerator of that first fraction here. That will allow me to cancel out the x plus 7's, leaving me with just the 7. So the numerator becomes 7 minus, then I'm going to do the same thing with the next fraction. Take all of this, distribute that to the second fraction. Well, that would go on top where the 1 is, which means the 7's would cancel out, leaving me with the x plus 7. Now you definitely want to keep the x plus 7 in parentheses because that negative in front of it needs to distribute, otherwise things will not cancel the way they should. In the denominator, I actually do not want to distribute because my goal is to actually cancel out the indeterminate form. And so if I'm trying to get something to cancel out, then I'm going to need everything to be in factored form, so it's easier to cancel eventually. So I'm just going to keep that as 7x times x plus 7 in the denominator. And then of course we have not taken our limit yet, so we're keeping the limit notation for the limit as x is approaching 0 out in front. Now that I've eliminated the fractions in the numerator, this will allow me to go ahead and start simplifying, and eventually this is actually going to become a lot easier. So first thing I want to do is go ahead and distribute that negative in the numerator. So I have 7 minus x minus 7. Again, not distributing in the denominator though. That way on the next step I can cancel things a little bit easier. And now you should see that things can cancel here. So notice, I have 7 minus 7 in the numerator. That will allow me to cancel those out. Now I'm left with a negative x over the 7x, so I can cancel this x with the x underneath. And doing so leaves me with that negative 1 on top. So now if I write what's left over, I have the limit as x is approaching 0 of negative 1 over the 7 times the parentheses x plus 7. And so now I can go back and actually evaluate my limit by plugging in the 0. So if I plug in 0, now I can actually drop the limit notation in front because I'm actually evaluating the limit, and I'm left with negative 1 over 7 times 0 plus 7, which simplifies to negative 1 over 7 times 7, which is 49. That would be the limit or the y value that the graph approaches as x approaches 0. So let's look at another problem. So now let's look at another one. Let's say I want to evaluate the limit as x is approaching 1 of 1 over x minus 1 over x minus 1. Again, first step, plug in your limit and see what you end up with. If I take this 1 and plug it in for every x, I'm going to end up with 1 over 1, which is 1, minus 1 over 1 minus 1. So I end up with 0 over 0, which again is called the indeterminate form. So that tells me I actually need to go ahead and evaluate the limit by simplifying algebraically. And to simplify algebraically, I'm going to multiply by the common denominator. So in this case, I only have one denominator, and that is x, which is in the numerator with that 1 over x. So I'm just going to multiply the top and the bottom by x. I don't need to multiply by more than that because I do not have another denominator. So if I take this x and I distribute it to that first fraction, that's going to allow me to go ahead and cancel out the x's, leaving me with just the 1. If I distribute that to the second term, then I just have minus x. And then with the denominator, I'm not going to distribute those terms. That way I can cancel in the next step. And again, I have not evaluated my limit, so I'm keeping the limit notation out in front. So now, notice the numerator is very similar to this term in parentheses in the denominator, but the signs are messed up. So what I need to do now is go ahead and factor out a negative from the numerator. So I have the limit as x is approaching 1 of negative parentheses x minus 1 over the denominator. And now that I can have the same term on the top and bottom, I can cancel those out. Remember, that's actually a hole on the graph, which is what is causing the indeterminate form, 0 over 0. And I'm just going to go ahead and clean this up a little bit. I'm going to go ahead and rewrite my limit. So I have the limit as x is approaching 1 of negative 1 over x. This is as simplified as it can get. So now the last step is just go back and plug in x is 1. So I have negative 1 over 1. So the y value that the original equation goes to on the graph would be negative 1 as x is approaching 1.